Hey everybody. Okay, so hopefully you had a chance to see the little checking in video that I posted right before this one. Um, we had little, tidbits of information that you might want to know about, and this was one of the things that I was referencing there. So here's the red color that I was talking about. So that's what you're looking for this lesson. So I do want you to upload these things as in place of your homework tonight. All right. So you should get this done during the lesson. During the video lesson, and then you won't have any exercise work to do. But so here's the first thing I'd like for you to do. So go ahead and press pause, and then when you've completed the work, go ahead and press pause again to finish the video off, and you'll see some lessons that go along with it. It's very important that you do these before I show you how to do them. Just want to see what you remember, and then if there's things that you thought were true or that aren't, you can make those corrections in your notes to make sure you understand what you should do versus what you thought you should have done. So go ahead and press pause, and then solve these problems, and I'll talk to you in just a second. Okay, so hopefully you had a chance to do those problems, and we'll come back and revisit those problems towards the end of the lesson today. So you may or may not remember what this topic is, but this topic is actually called order of operations. And the order of operations is the order by which we must do a math problem in order to get it right. So what I mean by that is I've had students in the past, they thought that some person, probably a dude, just said, oh, I think we should do this first, and then I think we should do that operation second, and let's not do that one until the last, or whatever. And that's not how it worked. How it actually worked was that, as with most things in mathematics, that we looked at data, and if you didn't do it in this order, then you didn't get the correct answer. So the only way we got these answers right was if we did them in this order. So an example might be is if I have, I have 50 animals. Okay, so I have 50 animals. And then I have 2 pens that have 10 sheep. And I've got in each pen, and I've got 3 pens that have 2 ducks. I don't know, doesn't matter. And then the rest are pigs. So the question is, how many pigs? All right. So if I were to write that out into a math problem, I would say, okay, well, I've got 50 animals, and some of them are sheep. And what I have is I have 2 groups of sheep, and in each group there are 10 of them. So then if I subtract those away from my 50, that'll tell me how many I have left. And then beyond that, I have 3 groups of 3 pens, or 3 groups of ducks. And so I have 3 groups of ducks, and inside each duck, or each of those groups, there's 2 ducks. And whatever's not in these 2 groups of pens are my pigs. So what I would need to do then to figure this out is I would need to subtract, or actually let me do it like this, subtract this away from that. Okay, so I have my 50 animals, and then I'm going to subtract this away from that. So our order of operations tell us, by looking at this, what we have to do first. So our order of operations then would say, okay, well, we've got to do this big old group over here first. And then inside of this group, we need to do these little subparts. So you might look at it and go, well, am I supposed to add 10 to 3 or not? And I'm sure that many of you know that that's not what we do. but it is technically an option, right? So if I wrote this differently, I wrote it like this, 50 minus, and then 2 times 10 plus, I'll put the dot in there, make it look a little bit easier, 3 times 2, and then parentheses. So now you can see that it's, it's a little bit more confusing about what you should do first. If you might go, well, I think I should probably go 3 plus 10 first because adding is easier for me than multiplying is, or whatever a student might say. But we know that that's not okay. You don't get to do it in any order that makes sense to you. You have to do it in the order that's going to work. So here's the example of why order of operations has to be taught and learned in a specific order. Because you can't do this problem 2 different ways and come out with the same number of pigs. That just doesn't work that way. So the only way to do this problem is if we apply the order of operations correctly, okay? Okay, so that's my general example. I don't even care if we figure that answer problem out. We're gonna go back and do some other problems first. And let's take a look. Okay, so order of operations. So what do you remember about order of operations? Well, I'm guessing that many of you remember this. Okay, many of you remember this for order of operations. P-E-M-D-A-S. All right? If we were in class, I'd probably ask you guys to raise your hands. Who remembers P-E-M-D-A-S? And many of you, if not most or all, would raise your hands. They'd say, what does that equal? And a large number of you would then say, please excuse my dear Aunt Sally. Right? That's what you would say. Please excuse my dear Aunt Sally. And which is hilarious to me because please excuse my dear Aunt Sally is a way to remember the order in which you do the order of operations. And the order in which you do the order of operations is P, then E, then M, then D, then A, then S. So they kind of do the same thing. If you already know this, there's no reason to remember, please excuse my dear Aunt Sally. Just remember PEMDAS, okay? It might not be too surprising to you, but it might surprise a few of you that I hate this. I absolutely cannot stand PEMDAS. I think that if you are a teacher who is going to teach PEMDAS, you are going to be not going to be as effective as you could be. There will be a % of students who do not understand why they're getting it wrong because they're doing what you ask them to do, meaning they think they're doing PEMDAS. And so here's the first issue that I have with PEMDAS. When you look at this and you ask students, how many levels or how many order things are there? And they would say, well, there's 1, 2, 3, 4, 5, 6 different levels that you can do. You could do the P first, or the E, then the M, the D, the A, and the S. And there's probably a fair amount of you right now going, yeah, that's not true. That's not the way it works. There's not 6 different levels here. And I agree, there are not 6 levels. How many levels are there? Well, there's actually only 4 levels. And I've seen people kind of do this in different ways, trying to show this. Sometimes I see teachers do this, right? So they go the P and the E, and then the M and the D go together, and the S go together. I'm kind of okay with that. That's better than just writing out PEMDAS. But this is what I actually use, and this is what I prefer. Okay, so the first thing that we're going to do is always the P. And we'll talk about what the letters actually represent. So we always do the P first, okay? The second thing we're always going to do is the E. But I'm not going to write it like this. When I write it like this, it looks like the order has to go in this direction. And you're going to see in a second, it doesn't have to go this direction. I am always going to do my P first, and I am always going to do my E second, but I'm not necessarily going to do my M third, and my D fourth, and my A fifth, and my S sixth. So instead of writing it like a word, I'm going to actually write it going up and down. When I write it going up and down, I can now show which ones go together. So I've got my parentheses come first, then my E, which is my exponents, and then M and D. And M and D are the same level. Actually, I need to change. Actually, I won't change yet. M and D are the same level. So what I have my students do is I actually have them do it like this. Whoops, not like that, like this. Okay? And then I have them do it like this for the adding and subtracting. All right? And what that does is it reminds them that these are the same level. There's only 4 levels. There's only 4 orders of what you do. You do this one first, then you do that one second, then you do these 2 together at the same time, third, and the last thing you do are these 2. So the question here is, how do you know which of these to do, or does it matter? Can you always divide then multiply? Can you multiply then divide? Does it seem to matter? And so what I have my students do is on these 2, they do this, LR and LR. What does LR mean? It means left to right. So you're going to do whichever one of these comes first, the D or the M, from left to right. Then you're going to do whichever comes first, left to right, and the S and the A. So you might subtract first, or you might add first. But you're not going to add before you divide or multiply. You're always going to divide or multiply before you add and subtract. And I put quotes around always, and we'll see that in a second. And that's why I don't like the P, actually. But you're always going to do the E before you do the D or the M or the S and the A. This one always comes first. And again, quotes around that because there's some times when it's not necessarily always first, and that's why I don't like the P. Okay, so the question is, why does everybody all across the country / world, or maybe not world, but certainly country, why do they all use Pemdas if it's not really that great? And I can show you exactly why we use Pemdas and not something else. The reason we use Pemdas is because this is hard to say. That's the only reason we use Pemdas, is because it's easy to say, where Pemdas is difficult to say. It's equally correct as Pemdas. You do parentheses first, you do exponents, and then you divide and multiply together at the same time, and then you do subtract and add together at the same time. So we could have done Pemdas, but that's a hard word to say, so we all learned Pemdas. I don't like this because this does not show that there's 4 levels, okay? So I have 4 levels. I have this group, then I do this group. Once those 2 groups are done, then I do this group. And once that's done, then I finally do this thing. So this is the last thing I do, and I'm gonna do it from left to right. So if subtraction comes first, I do that. If adding comes first, then I do that. Same thing with divide and multiply, where here it doesn't matter. Wherever the exponents are, left, right, up, down, doesn't matter. And same with this one. Okay, so I like this a little bit better, right? This is, 30% better than this. If I want to make it 100% better, then this is what I'm actually going to use. Okay, so now this one I'm going to do the right color coding. Okay, so my favorite way of doing this is not a P, but a G. Okay, we'll talk about the G in a minute. And then after that, I do the E, which is the same as there. And then I do the M and the D. And I do those left to right. And then the last thing I do is the S and the A. And I do those left to right. So the only real difference between this one and this one is I still have my 4 levels. So there's 1 level, 2 level, 3 levels, 4 levels, right? So there's my level still. The only difference is this right here. So I think I know what you guys use for this word. I don't know if we know what we use for this word. So if I look at this one here, I think you guys use parentheses, okay? That's the word I believe most of us use. So now I'm gonna look at a problem here, okay? So if I look at this first problem, right here, and you say, okay, how do you do this problem? And people go, oh, Pemdas. And I say, okay, great, write that down. So over here, they know they're not supposed to write it as a word, so they write it like this, M and the D, S and the A. Right, so they got their little Pemdas deal going on here. And then, okay, so what am I gonna do first? And they go, well, parentheses, okay, what do I do first? And they go, this one right here. Is that parentheses? I mean, yes, obviously we're using parentheses, but the question is is that the P of Pemdas? Or is this the exact same thing as if I had written it like this? Is there any difference between this and this? And if you say no, there is no difference, well then you're right. That's the exact same thing. So this is not the parenthesis that we're talking about. This is the parenthesis we're talking about. So I don't like using the P for parentheses because those are parentheses, and now you're confusing kids that we're not really talking about those parentheses. We're only talking about these parentheses. Well, what the heck? If a parenthesis is a parenthesis, then just use parentheses. So that's confusing, right? So that's why I don't like it. So instead of the P is why I like to use G. And G stands for, not for parentheses, but groups. Okay? So groups. Now I'm looking for groups, and I can identify where the groups are. Okay, I'll show you where that is in just a second. And then the E stands for exponents. Okay, that's the same for all of them. And then the M and the D are multiply and divide. And then the last one is add and subtract. Okay, so those are my 4 levels. We got groups instead of parentheses. Exponents, always. Divide and multiply, always. Subtract and add, always. And for these two, remember, it's left to right. And for this one also, it's left to right. Okay? So we'll look at those in just a second here. Okay, so groups, exponents, divide, multiply, subtract, add are the ones that I use. Now I'm going to go ahead and erase this and just put my letters up so that it's not in my way. So I've got G for groups, and then I've got E for exponents. I've got M and D for divide and multiply. And then I do an arrow like that. And then I got subtract and add. And I do an arrow like that from left to right. Okay. So now, going back to the groups one, because that's probably the one that's most different for you or most foreign. So the question is, where is a group? How do I identify that I have a group? Well, this is the easy one. Clearly, those parentheses make up a group, okay? So my group is sitting right there. It's easy for me to see. And that's when parentheses would have worked. The P would have worked fine if I'm talking about that. But in this one, the groups aren't quite as obvious because I'm not denoting them like I am over there. So, okay. So here's where my groups are located, all right? My groups are located anywhere there is an addition or a subtraction sign in my main problem. So I see I have an addition sign here. That separates 2 groups. I have an addition sign here. That separates 2 groups. I have a subtraction sign here. That separates 2 groups, okay? So anywhere I see addition or subtraction in my main problem, that separates my groups for sure. So now I can say, okay, the great thing about doing it this way is you get to do any group you want in any order. It doesn't say you have to do left to right for groups. So if you want to do this group first and then this group and then that group and that, great. Do it whatever order you want. Just do your groups. Most of the time, I just do my groups right on down the road. So for this one, I have nothing to do. So I'm just going to bring down the 8. Now I look inside this group here and I see that that's multiplication. So I'm going to do my blue level. So I have multiplication here. So 2 times 3 gives me 6. And then I still have my plus sign. So I bring that down, right? So I still got that. Then here, I still have my plus sign. I have 6 times 5. So that's 30. So that's also in blue. And then over here, I just bring that group straight down. I still have my minus there. And so that is 4. So now what I have is 8 plus 6 plus 30 minus 4. And what you notice there is I'm all the way down to my bottom row. I'm all the way down here. So now I'm ready to do my subtract and add, and I do that from left to right. So I'm going to do these 2 first. 8 plus 6 is 14. And then plus 30. and those two equal 44, and then minus 4 gives me a total of 40. And there's my final answer. And I've done it exactly the way order of operations would ask me to do it. I've done all of my groups at the same time first. I didn't have any exponents, so there's no red in here. Then I did my divide and multiply. That's the blue sections, these two. And the last thing I did was my purple, which was subtract and add from left to right. So I started here on the left-hand side, and I subtracted and added and went to the right. So I added first, and then I added again, and the last thing I did was subtract and got to my final answer. Okay? All right, so now let's take a look at that bottom one there. We're gonna do a similar thing, right? So I'm gonna write I always write this on the problem when I'm doing it with my students, so that they get used to seeing it and they start writing it hopefully the correct way as well. Okay, so there we go. Now, first thing I'm gonna do is I'm gonna identify my groups. So anywhere that I see adding and subtracting is a group. So right here is a group because of that, that's a group. Here's another group separated, right? So that's a group. And then this whole thing is another group. Okay, now inside of, well, let me just go back and do it. Okay, so now I can do my groups in any order. So I'm gonna go ahead and start here and do this one, although I could do whichever one I want, but I'm gonna do this one first. So 3 times 6 gives me 18. And then I have this group, which is already done. So that's gonna be plus 2. And then plus, and now in here, I have some stuff to do. So this signifies yet another group. So I'm going to do a little line like that because this group has to be done first. So I do 8 plus 6, which is 14, and then divided by 7. So this group is not done yet because I have this little subgroup right here that has to be done. That's still part of this whole big group over here. So that means I'm just going to go ahead and bring this number down, 18, and then plus 2, that's that one there. And then I still have to do this one, which is 14 divided by 2, which is 2. Okay, and now I have all of my groups done into, I'm just adding and subtracting. So then I have 18 plus 2 gives me 20, and then plus 2 gives me 22. And there's my final answer. Okay, once again, no red. And the reason I don't have any red is because there are no exponents here. Okay, all right. So the next thing I'm going to show you guys is there's a part that's going to go into your homework. You'll see the red directions there, part that goes into your homework, and you're just going to answer the question that I have there. All right, so here we go. Here's one question I have is this. So you're going to press pause in just a second and then answer this question. Which of these two problems would students think is more difficult? And then tell me why. So you include that with the first problems that you did at the very beginning of the video. So which of these two problems is the most difficult for students, do you think, and why? Okay, so now would be a good time to press pause, and then we will talk about it in just a second. Okay, so hopefully you had a chance to say which of those two problems you think is most difficult and why. And I'm hoping that most of you said this one is most difficult, because it definitely is. Okay, so this is the harder of the two problems, and the reason is because it doesn't show this symbol, right? So this symbol right here makes it a little bit easier than this one up here. So we're going to go ahead and do this problem like we've been doing the other ones. So I start with my G, okay, and then I'm going to do my E. And then I'll do my M and D. That's left to right. And then lastly, my subtract and add. Okay? All right. So first thing I'm going to do is identify my groups. Well, we said a second ago that groups are identified by adding and subtracting in our original problem. So this is a group here. So that's 8 and then minus. Now this one is the one that has what makes the Pemdas very difficult, because there are no parentheses. I'm going to tell you something that's kind of embarrassing that I used to do when I first started teaching. I used to try and get my students to, quote, remember that there were invisible parentheses right here. That is one of the dumbest things I've ever said to another human being. No kid is ever going to remember there are invisible parentheses right there. So we have to teach it differently. I don't want them trying to remember something that's invisible. Instead, I'm going to say, okay, this top part is a group of numbers that is all being divided by the bottom part. So the fact that I don't have a single number on top means that I have to do that subproblem or that group of numbers so that I can then divide. It's possible to do this without having to do the top first, but it's just a lot harder problem. So instead, what I'm going to do is I'm going to figure out what the top is. So 10 minus 4 gives me 6, and then divide by 3. Okay? I will tell you, it is possible to do this problem and still get it right. That is the same thing as what I have over here. The problem here is you're now connecting some fractions together. So what you go, oh, hey, common denominators. Sweet. My common denominators then are 3. And so 10 minus 4 gives me 6. And my denominator stays the same, which is what we got right there. So no big deal. Okay? So you don't have to write it that way, although you can. Okay, so now I'm ready to move on. This is not done yet, so I'm just going to keep bringing down my, my groups that are done. And here I have 6 divided by 3, which is 2, like that. So now it's 8 divided by 2. And my last answer, of course, you do the subtraction left to right. So that is 6 for my final answer. Okay. Now when I look at this one actually, although most people would probably have said this was a little bit easier, it actually ends up being a little bit harder because you do have to deal with fractions here. But I'm going to do the order of operations, and I think most of us will say, oh, that, we would have said originally, yeah, I did think that was easier, but now I see why that one perhaps is easier. So what I'm going to do, like I did before, is my groups. So here's my group. That's telling me my groups are. So I've got 10 minus, and then over here, that's a group because we have the parenthesis thing. So I'm just going to do 9 minus 2, which equals 7 divided by 2. And all right, so I'm not quite done with this group because I still have some junk to do over there. So I'm going to bring this down. And now 7 divided by 2 gives me 3.5. And you can see why students would struggle with this problem more, even though we thought this was going to be the harder problem because we didn't see the parentheses there. This looks like the easier problem because of those parentheses, but this one actually ended up being easier because the mathematics was easier. Here they got to learn how to subtract 10 minus 3.5. Hopefully at this point we're pretty good at that. I'm going to do this. We're going to do 9 and 2 over 2 minus 3 and 1 over 2, which is equal to 6.5, or however you do it. I don't really care at that point, but you get to the right answer. Okay? Okay, so there's a couple of problems. Now we're going to take a look at a couple more problems that have to do with order operations. Same thing as before. I'm going to have you guys go ahead and press pause here for a second, and going to upload this to your homework. And once again, you're just telling me, of these two, which do you think is harder for the students to do? Is the top one harder or is the bottom one harder? Okay. Okay, so hopefully you had a chance to tell me which one was harder. Before we do that, we're going to come over here and do another one. And now look at these. Same thing. You're going to add this to your homework and upload it for this week's homework. So look at these 4 problems. I actually want you to figure them out. I'm not asking which one's harder or whatever, anything like that. What do they equal? So figure out what that equals, then that, and then finally that one down there. So go ahead and press pause and do your solutions over here for me. Okay, so hopefully you had a chance to do all of those, and we're going to start with these first, okay? And then we're going to come back and do the ones that were on the board just a second ago. So now I'd like to do these in easiest to understand order to maybe most complicated understand order, okay? So the easiest one for us and our students to understand actually is the last one. Because this is a complete, what we call a complete problem that makes sense to us. This says 3 take away 4 squared. So I can go ahead and do my order of operations. So I've got my G, And then I have my E. And then I have my D and M. And I have my subtract and add. Okay, so this one is the easiest one for us to do because we actually can apply Pemdas to it. So when I look at this, I say, okay, well, that separates my groups. So I have 3 minus, and then 4 squared is equal to 16, and that's my first exponent. So I can write down 16 here. Right, this that separates my two groups there. So now I end up with 3 minus 16, and you know, you might do keep, change, however you do that, bingo, bongo, and then you end up with 1 plus 2 minuses, circle one of each, and I get negative 13 for my answer. Okay, so not saying the answer was easy, although the math of it makes a little bit more sense because we didn't actually follow order of operations. Okay, so now I look at the next one. What do I think the next easiest one might be? And this might have been the first easiest one for some of you. You might have looked and go, oh, of course I know this one. So I'm gonna go back up here. I think A is probably either the easiest one or the second easiest one for us to do. So if I were gonna write this one out without exponents, what I would actually write would be this. -4 times -4. Do we agree that when you have this, it's actually equal to whatever's inside your parentheses being squared means -4 times -4? I think we all agree with that. So here I have the signs are the same. When the signs are the same, I make the sign positive, and it's going to be equal to 16. So this one is equal to 16. Okay. So now what's the next easiest one? Well, I think that now they're getting these three a little bit tricky for the set. I mean, this might be a personal preference here on what's the next easiest one. I think C is probably the next easiest one. And here's why I think C, because what this one tells me is that I have a negative of 4 times 4. That's what this would be equal to. That minus sign is outside the parentheses, so I don't put it inside like I did up here. It's actually outside. So 4 times 4 squared is equal to 4 times 4. So 4 times 4 is 16. And then I have that minus sign there. So that's going to be equal to negative 16. Just like that. Okay. And then having done that one, I think the next easy one probably is D, actually. Because these two look very, very similar in that has a positive 4 on the inside. And this one has a -4 on the inside. So it's kind of like that one, just with that on the outside. So I think I probably could write that one as like this, -4 times -4. And so -4 times -4 gives me positive 16. But then I still have that negative on the outside, so it's going to be equal to negative 16. Okay? Which leaves me with that one right in the middle. And I'm guessing that a lot of you thought this was a pretty easy problem, and many of you did this for your answer, positive 16. Notice that I did not do any work there because that is not correct. I know you're freaking out right now and you're getting mad at me. And if we were in class, you'd be chucking stuff at me, but that is not right. This does not equal 16. Let me give you an example here. I forgot something in this problem. So we did this one as the easiest one. And the reason I said this was the easiest is because you kind of see the problem. I forgot to write a number here, here, and here. So what number could I put there that's not going to change that answer? Well, if I put a 0 in here, so now it's 0 minus -4 squared. So if I'm doing this order of operations, here's where my line would be. I'm going to do this first. So -4 squared gives me 16. So then I would have had 0 minus 16, which equals -16. If I had put a 0 in here, this is going to be 0 minus, and then 4 squared is 16. And 0 minus 16 gives me -16. So if I put a 0 in here, this is, put a line in there, 0 minus 4 squared, which is 16, which is equal to negative 16. This one right here, without parentheses, is equal to negative 16. It is the same as these ones down here that have a negative on the outside. The only one that ended up being positive is when the negative sign is inside the parenthesis. So that's the only one that's positive. Every other one, because I had a negative on the outside of these, ended up being a negative answer, right? So this is what you want to think of. If you put a 0 in front of it and it doesn't change the problem, it's now 0 minus 4 squared, or 0 minus parentheses 4 to the second, then that you have to do last, just like it's a subtraction. It brings it all the way down to the very, very bottom. Okay, so let's take a look and see what we did here. So a second ago, I asked you to tell me which one of these you thought was harder. Okay, and I don't know which one you picked, but the reason you picked whichever one you did is probably not the correct reason. This one is the easier problem to do. And the reason this one's easier, I'm going to do this one first because you probably did this one right. You probably did this one wrong. Okay, so we'll see. So the first thing I'm going to do is write down my G and then my E. I'm just writing it for both of them here. M and D. And then A and S. Okay? So, all right, so the first thing I'm gonna do is my groupings. So, all right, so I put a line there and a circle. So line there and circle that one, and then that's it. Okay, so now this one is 6 minus, and then inside this group, I can do the 4 squared, so that's no big deal, that's 16. And then inside of this group, I have to do the parentheses first, because that's one of those little subgroups. So I'm going to do it like that. So then I'm going to have the 3 is still here, so minus 3. That hasn't been done yet. And then this is 5 plus 2, which is 7. And so that's actually purple. And then I still have my squared on the outside. Okay, so now I still got to finish this group off. So I have minus 3, but now I can do 7 squared. So that's 49. That should be in red, not green. Sorry. 49. And the reason I let the 3 still be black is because that hasn't changed at all. And then I have these over here. So I have 6 minus, and then I still have this 16. Still not quite done with this one, so I'm going to do one more row here of 6 minus, and then 16. And then 3 times 49 is 147, I believe. And that would be in blue. So that is minus 147. And now I'm going to do my, subtraction down here. So here I'm going to have keep, change, change, bingo, bango. 1 plus 2 minus, and then I'm going to, and I'm doing this from left to right, by the way.